So we've talked about circle graphs and bar graphs, which we use for discrete data. Discrete means you can separate it into a limited number of categories and then count the amount in each category, okay? But what if we have data that isn't like that, that isn't easy to separate, okay? I mean, it can be separated, but originally it's not, there's just too many different categories, or categories, quote unquote, okay? That type of data is usually numbers that have fractions in them. So things like height. I mean, you can't, you know, if you look at height originally, everybody's a different height. They could even be off by like 0.00001 centimeters. But everybody's different, and we can have fractions of height. So you can have fractions of a centimeter, fractions of an inch. So that is not discrete. We can't put it into separate categories. I mean, we can for graphing purposes, but originally we can't. That we call continuous data, okay? Continuous data are things, you can't count them, but you can measure them. So continuous data would be things like distance, because you can travel part of a meter or part of a kilometer. Time, you can travel part of a minute or part of an hour or part of a day, okay? Height, weight, all of those things would be continuous. So before we get into how to take continuous data and put it into a graph, tell me about these ones. What you think these ones would be? Would it be discrete? You can put it into separate categories, not too many categories, or would it be continuous? You could have fraction amounts, and there's just too many different amounts you could have. So the amount of water in a water cooler as it's poured out, continuous, right? Because you can have, I mean, amount of water could be measured in milliliters or liters, and you could have fractions, so it's continuous. The length of a pencil, continuous again, because if you measure it, say, in centimeters or millimeters, it's possible to have a fraction of a centimeter or a fraction of a millimeter. So it is also continuous. How about the weight of different dogs? Yeah? Could a dog weigh a fraction of a pound or a fraction of a kilogram? So wouldn't that mean continuous? The number of markers in a package. Yeah. Because you can't have like half a marker or 3/4 of a marker. Like a package will have 8 or 12 or whatever. So that's discrete. So how do we take this continuous data so we can graph it? Because like if we were to do the weights of different dogs, I mean, like it would be just a graph that would take forever. Like what if you went to a daycare and measured or weighed every single dog? I mean, some doggy daycares have like 70+ dogs, and every dog is going to have a slightly different weight. So that means you would have, if you wanted to make a bar graph, you'd have to do 70 different categories, okay? Or if you wanted to make a circle graph, well, you couldn't even make a circle graph out of that. So what can we do to the data so that we can graph it and it does have some meaning? We can put it in groups, okay? So for example, we could, if for different dogs, we could say, okay, we're going to count all the dogs from 0 to 5 kilograms. And we're going to count that as a group, okay? And then 5 to 10, and then 10 to 15, and so on. And we're going to separate, so we're going to make categories out of them so that we can graph it. And when we make categories out of it, we get what's called a histogram, which is like a bar graph, except all the bars are right beside each other. This is an example of a bar graph. So marks for a math test. So notice the bars are right beside each other. So this one, now, one of the disadvantages of histograms is we don't, like, all we know is that 4 scored from 0 to 49%. We don't know what the marks were. We just know that they were somewhere between 0 and 49. And then 6 scored between 50 and 59, and so on. Okay? So it allows us to graph the data, but it does have its disadvantages. So this, a histogram, is what we use for continuous data. Taking continuous data and putting it into distinct categories. So if you could pull your laptops, how do we make one using Excel? So age, so here for this example, Statistics Canada, who's responsible for collecting a lot of information on Canadians, surveyed the population to figure out how many people lived in Canada and then broke it up by age. Well, everybody has a slightly different age. So Canada has over 35 million people in it. So if you tried to do a bar graph, you'd have like 35 million bars, which would have absolutely no meaning. So we're going to group them. We're going to put them into age groups. So the categories will be much smaller. Okay.
Every time I put 5 to 14, it changed its date in May every year, and I can't make it stop.
Are you putting dash 14?
Yes.
Put 2. Yes. Otherwise, it's going to do that to you. Yeah, that's the thing. If you just put numbers in this first column, it won't show you a histogram properly. And so the first thing that you're going to do, which some of you have already started doing, which is good, after opening up an Excel document, type these as you see them in the first column, A, going down, and then you type the number of people. You don't have to type these titles, age and number of people. We'll put that in our histogram like we did with bar graphs. So the first step is to type all these things in. And remember, when you type numbers in, like big numbers in, even though there may be spaces between the digits in the table, you can't put spaces in Excel because it won't recognize it as a number. So once you've got everything typed in, highlight everything you typed in, go to Insert, go over to the bar graph. It's the little graph on the upper left in the middle of the top. And select the first one. We okay with that? Make sure you got to ask me if you're not sure. When you select that, you should see something like this. It's a bar graph, but it's not quite done yet. Excellent. You guys, you good? So just like we did with bar graphs, eventually this is going to become a histogram. We got to do one special thing to it here. But just like you did, click on chart title and change the name. So just change the name to Population of Canada, a more appropriate title. And then you just hit enter and you're good there. Once you've got that done, go to the upper left corner where it says add chart element. And we're going to enter labels for the horizontal axis and for the vertical. So go to add chart element, go to axis titles, click on horizontal, and a box will appear at the bottom, and just put age range. Type the title age range. That'll be sufficient. Or even just age. I just put age. Go back to that add chart element, axis title, this time choose a vertical one. And under the vertical one, put number of people. Now, that's like a completed bar graph. We're almost done, but it's not a histogram because the bars have to be right beside each other in a histogram. Are we all here? Hannah, you okay? Okay. So what we need to do is we need to change the width of the bars so that they're beside each other. So what you can do to that, go to one of the bars here, right click on it, and it should say format data series in one of your choices. If you select that format data series, a window should pop up on the right, and at the bottom, it says gap width. Do you see that? Yep, perfect. Change that to 1%, the gap width. Change the gap width to 1%. Because that means there'll only be a 1% separation. Okay, go back to the bar, right click. No, right click on it, see what happens. Oh, crap.
That's what it brings.
Okay, shoot. This is the online one? Crap.
Change the layer.
Oh, maybe data labels. Let's see what we can put it in. So. Why can't I?
Maybe.
Oh, now that comes up.
Why don't you just get the desktop Excel?
Because I don't even know. It's so hard because I don't know my password to a bunch of things.
Well, you're gonna need it.
Yeah.
So if you choose 1%, Yeah, there you go. This is what it's going to look like. It's going to thicken all the bars. And we're done. That's the histogram. So I would suggest you save that as, what did I say, lesson 2.3 histogram or something like that, just so you have a copy of it. Every one that we do in every lesson, you should be saving it, just so you have a copy of it. And then, of course, you can play around with it if you want. There's different ways to show it. You can change colors and stuff like that. Okay? You don't have to, but. And that's how we do a histogram on Microsoft Excel. So now that we know how to construct it, if we've got a histogram, how do we interpret it? And a lot of interpretation of these graphs, oh, sorry, before we do that, did I have interpretation before? Oh, no, I did not have interpretation. That'll be the last lesson. There was a second part to this question. A was to make the histogram.
And then it's looking through.
Right. So, and this is where a lot of times there's no right answer. As long as you can support your answer, you're good. Okay? Because everybody sort of has different opinions when they look at a graph. So when I look at this graph, sorry, I'll bring it back. So what jumps out at you? 25 to 44. Yeah. That's probably the first thing that jumps out. So the majority of Canadians are actually, well, I don't know if I should say majority, because majority implies 50% or greater.
I just said they're mostly 25 to 34.
Yes. You know what? Yeah, I agree with you. Most Canadians are in the, most Canadians are in the 25 to 44 range. Yeah, you don't want to say majority, because majority implies greater than 50%. Even though the 25 to 44s are represented the most out of all the different age ranges we've separated in, we don't know if it's 50% of the population. So that's why we can't say majority technically. Yeah, yeah. The smallest group is the 85 plus. Absolutely, you could write that. Usually that's how, a lot of times that's how our first analysis is, our initial analysis. Look for the greatest, look for the smallest. And even sometimes you can look for the same. Because it looks like the 15 to 19 and 20 to 24 are pretty close to the same. Along with even the 65 to 74, they're all pretty close. So again, you can make a lot of different conclusions, and they're all correct. But usually you want to look at the highest, the lowest, for sure. Okay? Can you tell me something that would be misleading about this graph? Look at the age ranges. Are the age ranges a constant difference? This is a difference of 4 years, or 5 years. This is a difference of 10. Then it goes 4, then it goes 4, then it goes 15 in the one that appears the most. So that's deceptive. If we split them all up into the same difference, maybe we get a better idea of what the largest group is. Okay? Graphs can always be deceiving. You want to make it look like you have a young population? Make the young age categories wider. Then there'll be more of them and it'll be taller and it'll make the older ones smaller. Okay? You can always manipulate graphs and information to tell a story that you want to tell. Okay, finally, advantages and disadvantages. So an advantage would be it summarizes continuous data nicely. Grouping into categories, this kind of goes along with the first one. Grouping into categories allows us to see patterns. You know, trends. Does the age go up? Does it go up and come back down? What's the most common age group, etc.? I think I'll leave it at like that because I've got a third one, useful when describing a range. But that sort of goes with number one, summarizes continuous data nicely. Okay. The big disadvantage, it does not include exact data values. So in that one that we graphed, you know, we've got the age range groupings like 0 to 4, but we don't know how many are 1. We don't know how many are 2 or 3. Okay. We only know how many are 0 to 4. Hard to compare. With other histograms or other data. If the range of bars aren't the same. You can't have a double histogram or a triple histogram like you can have double bar graphs and triple bar graphs. So if you want to compare histograms, like let's say you wanted to split not only the, you wanted to figure out the age range of the population in Canada, but break that down by male and female, you got to make sure the age ranges are exactly the same in both histograms. Otherwise, you can't compare them. Okay. And, well, like every graph, I suppose I should have put this as a disadvantage for all of the graphs. They can be misleading. So in our example, remember, we don't want to use the word majority because that could be misleading. Okay. And we saw one of the age categories had a bigger range than the other ones. That can make it misleading. So we want to be careful of those things. Okay. Okay.